Hello, everyone. Today we're going to be talking about composition of functions. This is a pretty big idea in Algebra 2. Shows up a lot on testing and stuff. So I think it's kind of fun and interesting. Make sure you ask if you have questions. Okay, here's a little warm up. So Kalisha is purchasing a laptop. The original price of the laptop is $900. So what do we have here? We have a 10% off on all computers and a $100 gift card. How should she determine the amount she'll pay for her computer? Okay, so how can we figure that out? They want us to write, well, let's write a function for the discount. There was multiple choice and I took that out. So if it's a 10% discount and X is the original price, they want us to say P of X is the discount here. And if it's a 10% discount, how can you figure out how much it would cost? Well, a lot of kids want to say, well, you'll take the $900 and then you'll subtract 10% of the 900. A lot of honors kids like to say that, and that's not wrong. And if that was what you were thinking, you would take the price of the computer, then you would subtract 0.1 times the price of that computer. But these are like terms, and you have 1x minus 0.1. Actually, what you're doing, you're paying 90% of the cost. So you would take 90% of this, and then you would just subtract $100. So we would take 0.9 times 900, and then we would subtract the gift card. And it looks like she's going to be paying $710 out of her pocket anyway. This is where there are two functions, one following the other. First, we did the 0.9x, and then we took the cost and we subtracted the $100 for the gift card. So we had a function, and then we followed it up with another immediately. And that's what composition of function is. It's one function following the other. So we're going to write expressions, we'll find the domain, and we will evaluate them. Okay, so basically, whenever you have one function following another, we're creating these super machines. So for this particular case, we had the 0.9x machine, and then that guy fell right into the x minus 100. So you would dump in the price of the computer, which was $900. It shot out 810 after you took the 90% of it. And then that guy went right into the second machine, subtracted 107, 110. So the output of one function became the input of the next. And so what we are going to do today is when you have this super machine like that, we're going to try to encase it into a machine like this, and then we are going to come up with one rule that combines the both of those together. And that's what composition is, so that whenever you just plug 900 into the one rule, it immediately shoots out 710 instead of having to go through one piece and the other. So composition of functions are basically super machines. It's one function after the other. The new function is called a composite. Okay, how can we write this and what happens first? So in this one, F is happening first, and then G is happening second. Remember the order of operations. So the first way that most kids like to write it is you write whatever happens first, and then whatever seconds on the outside, because you start with the innermost parentheses, and then you would do the second thing. This is the way we read this. It's G of F of, of X. Start here, get an answer, then plug it into G. This can also be written like this: G, open circle, F. And what this, you also could say G of F when you read it. Like, think of the open circle as an of sign. It's a composite symbol, but this symbol actually means follows So that means G follows F, which means F happens first. Most students, if it is written this way, immediately write it this way. This way makes more sense to kids, and it reminds you what happens first is what's the innermost. So those are the two ways we can write it. Okay, so let's practice with this notation. How else can we write G of H of X? So what happens first? H of X is happening first. So G is following H. So you can write G of H of X. You can put the X afterwards. I don't think I did that earlier. Okay, what do you do first in G of F of X? You start with the innermost parentheses. So what do we evaluate first? We first evaluate the F of X. Mapping notation, I haven't used much with this, but basically this one is having G happen first, as you can tell. So this is the domain of G. This is the range of G, which actually happens to end up being the domain of F. So the range of G is the same thing as domain of F. And then for the whole thing, this would be the domain and this would be the range. So there's like all these little components here. So what this is doing basically is it's drawing a machine without drawing the machine and just showing what you're plugging in and what's coming out. So for f of g of 3, we're going to go to g of 3. This is function g. Here is 3. And g of 3 becomes 9. And then the 9 is from the f. And what does that become? The 2. So f of g of 3 is the 2. The 3 became the 9 became the 2. Here is some practice with functions. This is the good stuff here. This is the type of stuff you'll need to know. G of f of 4. Always start with the innermost parentheses. So we're going to start with f of 4. Well, what is f of 4? F of 4 tells me to go to function f, take out the x, and put in a 4. 4 minus 7 is negative 3. F of 4 is negative 3. So my new problem becomes g of negative 3. Go to function g, take out the x, put in the negative 3, don't forget your parentheses here, and we get the answer of 9. So g of f of 4 equals 9. Now, do you think you'll get the same thing if you change the order? So, well, what is g of 4? Innermost is where we start. G of 4 will be 4 squared, which is 16. G of 4 is 16. So where I see this G of 4, I'm going to put the 16 instead. My new problem is f of 16, which is 16 minus 7, or 9. We did get the same answer here. This generally is not the case. I'm actually really kind of bummed out that they made you think that that was going to be the case. But let's see what happens here. G of f of negative 1. Well, what is f of negative 1? Negative 1 minus 7 is negative 8. F of negative 1 is negative 8. So now I will plug that into the function. I have g of negative 8. X squared, plug it in parentheses. Negative 8 squared is 64. What is g of negative 1? G of negative 1 is negative 1 squared, which is positive 1. G of negative 1 is 1, so my new problem becomes f of 1. That will be 1 minus 7, which is negative 6. So even though it looked like it could be commutative and order wouldn't matter, in these first two examples, on these second two examples, we see that is not the case. It is not commutative. Now, we just did a couple of pieces here. Now we're going to see if we can figure out how to make the super rule we were talking about. So f follows g. That's f of g of x. So if we're going to make the function, g is happening first, which is the x squared, and then that is going to fall into the x minus 7. What we are going to try to do is encase that machine into one super rule so that when I plug in the numbers that we just had on the back page, we'll get directly to the answer. So you still start with innermost parentheses, which is g of x. So now my new problem is f of, well, what is g of x? Well, g of x is x squared. This is a set of directions. This tells you to go to function f, take out the x, and in its place, put x squared. So I have x squared minus 7. That cannot be simplified anymore. So the rule for f of g of x is x squared minus 7. And if we go back to our last page where it was the f of g, I can, or one was f of g of 4. Let's see if we can get there. 4 squared is 16. 16 minus 7 is 9. That's what we got. If you plug in negative 1, negative 1 squared is 1. 1 minus 7 is negative 6. And that is also what we got. So we were able to come up with a super rule as a shortcut. What would the rule look like for g of f of x? Well, this time we're going to start with the f of x. So it'll be g of x minus 7. This is also a set of directions. This says go to function g. Here's function g. Take out the x and put in x minus 7 in parentheses. Now I can guarantee some of you will do this wrong and tell me that's x squared plus 49. That is not correct. If you have a quantity squared, you will have to double distribute. Some of you call that FOIL. X squared minus 7x minus 7x, that's minus 14x, plus 49. So the super rule, if f happens first, which is the x minus 7, and then it goes into x squared, the super rule is this complicated thing, which is x squared minus 14x plus 49. Let's see if this works. Oh, sadness. Okay, let's plug in the 4. 4 squared is 16 minus 14 times 4 plus 49. 16 minus 14 times 4 plus 49 is 9, just like we got before. If you plug in negative 1, it'll be negative 1 squared minus 14 times negative 1 plus 49. You get 64. So this is a shortcut for the super rule. Okay, 2 more practices with this. I'm putting my mask on, so I might be a little muffled. H of f of x. Start with your innermost parentheses, f of x, and we will have h of x minus 7. That tells you to go to function h. Here it is. Take out the x and put in x minus 7 in parentheses. So that's 2 times x minus 7 plus 3. You will have to clean this up. 2x minus 14 plus 3, which is 2x minus 11. So a shortcut to the function where f of x happens first and then it dumps into h of x would be 2x minus 11. What if we change the order and do h of x first? It would be f of 2x plus 3, which tells us to go to function f, take out the x. The parentheses here would be extra, but you can do it still. 2x plus 3 minus 7. Simplify. 2x plus 3 minus 7 is 2x minus 4. So if h happens first and then goes into f, you get 2x minus 4. If it's reversed, you get 2x minus 11. So if you're finding out f of g of negative 2, we're just going to rewrite it in the way that looks a little bit better. You will start with g of negative 2. G of negative 2 is negative 2 over 2, which is negative 1. So my new problem becomes f of negative 1, which is 6 times negative 1 plus 7, negative 6 plus 7, which is 1. Okay, here's some real world examples. I'm going to see how much we have left here. Just 3 more slides. Okay. So, computers are on sale for 10% off. We talked about that. If x is the original price, then the function can be represented like this. And this is what we were talking about. Some of you like to write it like this, the price minus 10%. This is a little bit more direct way. There's also a coupon for x minus $150 or $150 off. What is better to do first? Do you want to do the percent first, or do you want to do the coupon first? Well, the laptop function, let's look what we can do here. Let's write both equations. Let's write p of c of x, and let's write c of p of x. If I do this c of x first, this becomes p of x minus 150. Go to function p, take out the x, and plug in 150. 0.9 x minus 150 is 0.9x minus 135. What if you do the percent first? That would be c of 0.9x. Go to function c, plug in 0.9x where you see the x. It's 0.9x minus 150. So if the coupon happens first, you plug it into this. If the percent happens first, you would plug it into this. If the laptop costs $800, let's see what we will get here. 0.9 times 800 minus 135. 0.9 times 800 minus 150. This guy is $585. And this guy is $570. So which one is better for me? Well, I'd rather pay $570, which means I'd rather do the percent first. Many of you probably realize that you want to take the percent off of a bigger amount to save more money. If you do the coupon first, you're not getting the full coupon's worth because you're losing 90% of your or 10% of your coupon, because of the discount happening afterwards. Most of your retail stores know that. That's why Kohl's makes you do some of your things in a certain way. All right, domain issues. Do not forget the risk factors. When you look here, this guy has a risk factor, x cannot equal 0. This guy is fine. This will be negative infinity to infinity. So they want to know, can we do g of f of 0? Is that going to be a problem? Well, what is f of 0? Nope, you can't do it. F of 0 would break the machine. You cannot do that. And it would be because 0 is not in the domain of g of f of x, or f of x, which happens first. Now, could I do f of g of 0? Well, what is g of 0? G of 0 is negative 4. 0 minus 4 is negative 4. What's f of negative 4? from negative 4 would be 1 over negative 4, or negative 1/4. So you could do that. So how can that be? What happened here? Well, when you do g first, you have the x minus 4, and then that plugs into 1 over x. Nothing breaks this machine, this top machine, but this machine cannot equal 0 when you plug it in. But this machine depends on the one before it. So the rule has to be x minus 4 cannot equal 0. So the domain restriction on f of g of x is x cannot equal 4. If you can't see it from the machine drawing, your other option could be to actually find f of g of x, which would be f of x minus 4. Go to function f, plug in x minus 4, and that's 1 over x minus 4, and then look at the domain. X minus 4 cannot equal 0, so x cannot equal 4. Okay, how about this guy? What is the domain of g of h of x? Start with h of x. That's what will happen first. Will anything break the 3x machine? No, nothing can break it. Will anything break the 1 over x plus 2? Yes, something will break that. What can I not plug in there? Well, x cannot equal negative 2. But that guy comes from this guy. So that means 3x cannot equal negative 2. And if you divide by 3, x cannot equal negative 2/3. If you want to just find the rule and check after that, g of h of x would be g of 3x. Go to function g, take out the x, put in a 3x, 1 over 3x plus 2. You would know that guy cannot equal 0, and you can solve it as well. 3x plus 2 cannot equal 0. 3x cannot equal negative 2. X cannot equal negative 2/3. Okay, how about this one? F of g of x. So g is happening first. That is x plus 5. F is happening second. That is the square root of x minus 3. Okay, so what do I know about this machine? Nothing breaks the first one. What would break the second one? X minus 3 has to be greater than or equal to 0. So that means x has to be greater than equal to 3. That is in this one. But this is the machine that determines what plugs in there. So that means x plus 5 has to be greater than or equal to 3. When you subtract 5, you get x is greater than or equal to negative 2. That would be the domain restriction. If you want to look at the equations, f of g of x is f of x plus 5. Go to function f. This is kind of tricky. Take out the x, plug in an x plus 5 instead. You could use parentheses if you want. That would be x plus 2. That means x plus 2 has to be greater than or equal to 0. And x has to be greater than or equal to negative 2. Is that what I got the first time? I hope so. I didn't pay attention that much. Took a little nap. Yes, okay, good. Making sure. Okay, last example is looking at just set notation with order pairs. What is g of f of 2? Well, what is f of 2? F of 2 comes from this guy. F of 2 is negative 5. So then what is g of negative 5? Go here, looking for a negative 5, and it's not there. So we just say it is not defined. Or I must be dyslexic. So if there's not a pair, you could have an undefined value as well. It's not there. Okay, I think that's it. All you do is take notes today, so make sure you take good ones.